Okay, so now we have the heat map that we generated. And let me also say that with heat maps, you can generate them without the values or scores. So you can have them this way. And so depending on what you want and what message you want to get across, you can decide to use this or that. Now with heat maps, there's a color scheme that will help you to interpret your results and also identify patterns. So that is one good thing about heat maps. So the color scheme here helps you to know the scores or the values for each particular cell here. Now I will switch to the heat map without the scores. This will help us to easily identify and visualize the patterns here. Now this particular heat map is using a blue color scheme, and so we have light blue and we also have dark blue. So here light blue indicates a low score, and then a darker blue, or those with dark blue colors are indicating high scores. So let's use that to interpret the results. And so using that, we can see that in general all the classifiers had low scores for these two metrics, Cohen-Kappa and then Matthews coefficient, because from the color scheme you see that they are very light or somewhere between. So most of them were between this particular color range. So it indicates that with respect to these metrics, most of the classifiers had low scores. And so if you were to use just these metrics, these two metrics, I will say that the classifiers did not do well in general. But we have other metrics here, so you just use all the metrics to collectively evaluate, okay, the classifiers that we have. So let's proceed. So you can see that with the classifiers, if you look at these four metrics, accuracy, precision, recall, and the F1 score, they all had fairly high scores. Okay, they all have high scores here. So they were all within this particular range. So if you are to look at the models that perform very well, okay, what I see is XGBoost, SVM, and then random forest. Because if you look at the color scheme here, okay, and then comparing with the others, these are the ones with high scores, because a darker blue or dark blue indicates high score. And so these three, XGBoost, SVM, and the random forest, are the ones that perform very well. But because the scores are not here, it becomes very difficult to pinpoint the exact classifier which performs very well. Here, these three appear to all have high scores. So you can use the scores to try and then go deeper. So let's switch to the other heat map. Perfect. So now let's compare. We are going to compare just the three top classifiers. So if you look at XGBoost, 0.82, 0.82, 0.81, 0.81, we have 0.72, 0.72. SVM, we have 0.82 and then 0.72. Random forest, 0.82, 0.82, 0.82, and then 0.72. So comparatively, the top classifiers are random forest and then SVM, because they all have the same scores. Okay, the scores here are the same. And when we come to XGBoost, there is a slight drop. So 0.82, 0.81. And so these two are the top performing classifiers. That is what we have from this particular heat map here. Okay, if you look at all the metrics here, and then the classifier that performed the least, or that had low scores, the worst performing classifier was naive Bayes. That is what we have here. So using the heat map, it becomes easy to do this visualization and also compare the performance of the classifier. So that is one good thing about using heat maps. Okay, now even though naive Bayes is not performing well here, it does not mean that always naive Bayes will perform poorly. The performance of classifiers depends on a lot of factors. Okay, it can be the data, it can be the number of samples, I mean, there are a lot of things to consider. Okay, so even though in this particular experiment, naive Bayes is not performed well, it's not an indication that naive Bayes is a bad classifier. No. These classifiers have their strengths and weaknesses, and that is why it's important to always use several classifiers, and you can look at the one which gives you the best performance and then use that for your other activities. So that is how we use these heat maps to visualize and compare the performance of classifiers. So